Yeah, we show a lot of beveling, and this reminds me of the fact that we get a lot of questions from customers about the different bevel designs that exist in the market and the advantages of those bevel designs.
Yeah.
And Timo, as someone who encounters different machine brands and different bevel designs, can you shed some light on the different bevel types?
Yeah, it's a great topic, and I will do my best to simplify it as much as possible. You could distinguish two types of bevel units. So one is so-called torch center point bevel units, where the machine are created in a way that when the bevel axes are used, the unit rotates around the physical tool center point. So these bevels are called AC bevel units because, as already mentioned, they use two axes, A and C, mainly to set the bevel in the right direction and under the right angle. So the other unit that we see in the market, and that's all the one I saw on Voortman's plate machines, is so-called non-tool center point units, or sometimes also called ABXYZ. So this type of bevel unit does not specifically rotate around the tool center point. The bevel unit utilizes all 5 axes to adjust itself to specific cutting height and the direction and the cutting angle as well.
Yeah, indeed, and I think it's good to mention, Timo, that now with the acquisition of Müller Opladen, we have both bevel designs within our portfolio. So when we look to the plate processing machines, we use the non-tool center point bevel. So as you explained, you need all axes to position the torch in the right way. So the machine should be really dynamic. And we are using the helical rack and pinion gears on our moving gantry machines, and also linear guides to make sure that the machine is really dynamic and accurate, to make sure that we can produce nice bevels with that non-TCP bevel system. But what the nice thing is with that non-TCP is that we are really flexible with variable bevel angles and distances. So we can really reduce and optimize the torch to work distance with this type of bevel design. And yeah, as you know, when we can shorten the arc, and when we can make the optimal length for the arc, then we will reduce stress on the electrode, and in the end it will reduce consumable wear.